Algebra 1A, what's up? Hey, Unit 15, Objective 3, last unit, last objective, last day. Congratulations, you've made it. I'm going to try to make this as quick and easy as possible. What I would probably do if I were you at this moment is I would pause this video and I would write this down. Then we'll talk. So that's my suggestion. Pause now, write that down. Come back, we'll talk. All right. So today what we're going to talk about is number of outcomes. Now this comes in two forms, and the second form has two parts. Real quick. If we're taking one of a set at several steps, and my example for that will be, and we'll do that shortly, is what if I wanted to know, like, how many phone numbers can I make? So I'm taking one number for each position in that set. That is one of a set at several steps or several locations. We're going to use what's called the multiplicative counting principle. Super simple. When it comes to taking part of a set, so now I have a set of things and I want part of that, not just one. So I want 3 out of these 10 or 5 out of these 24 or whatever the case may be. That now will depend, is the order I choose them going to matter? If so, it's what's known as a permutation, an NPR. If order does not matter, there's no order involved, this is what's known as a combination, or an NCR. Now, I think the best thing that we should do right now is make sure everybody's set up calculator-wise. So if you have your TI-30, I'm going to show you one way. If you don't have that, you can minimize the video and pull up Desmos Scientific. And I'm going to walk you through both options. So hopefully you have that written down. We're going to talk about each thing separately real quick. But I first want to make sure that we can punch things into our calculator correctly. So what we're going to put in is we're going to put in an NCR. And what we're going to do is we're going to say that we have 10 things and we want 3 of those things. It's part of a set. It's a combination. Don't worry so much. We're going to explain that. I just want to make sure we can put this in our calculator. So TI-30 users. N is your total number of things. Okay? In our case, we have 10. So we will put 10 with that N. We're going to take 3 of those 10. So R is how many we want. Many we want, which in this case was 3. So we're taking 3 of 10. I should have put that at the top, I guess. So TI-30 users, this is how you're going to punch this in. So turn your calculator on. I want you to type in 10. And then right underneath the mode button, you're going to see PRB. Press that. Underneath PRB, you'll see NPR, NCR. That's what we're going to use. Go to the NCR, which is the second choice, so arrow down, select enter. You'll see 10 NCR in your display. Type 3, press enter. You should get 120. If you did, awesome. If not, make sure you can before you move on. Desmos users, you're going to type this in, only it's going to be slightly different. So if you pull up Desmos, see if I can do this by memory without going back to it. Underneath where you type stuff in, the scientific calculator part, you'll see main, ABC, then FUNC, which stands for function. So if you press that, and you'll see NCR at the bottom. Yours is slightly different. You have to hit that first. So if you type in NCR, it will look like this. And then you enter your numbers in order 10, 3. So you're going to enter in 10, 3. You're going to press enter, and you should also get 120. I can... Sorry, I didn't know when I minimized my video that it was just going to shut off. So if that ended abruptly and looked funny, I apologize. So yeah, you're going to go into your NCR. This pops in. You type it in exactly as you see here. You should get 120. So make sure you can do that. All right. Moving on. So let's talk about that multiplicative counting principle. Multiplicative counting principle is really simple. Basically, it's counting and multiplying. So if we're going to take one of a set in several positions, what we're going to do is we're going to count up number of choices for part A or for step 1, whatever you want to call it. You do the same thing for B. Count number of choices. You do the same thing for part C or third part or part D or whatever. So however many parts you have, you do the same thing. Okay? Once you count up those choices for every step along the way, you just multiply them together. Now, if you're sitting here going, what are you talking about? Let me show you. So let's take license plates. So we're looking at a license plate. Let's take a license plate and let's say that a license plate starts with 3 letters and then finishes with 3 numbers. So an example of this would be a license plate like KFZ157. So there's a license plate. I want to know how many ways can I make a license plate like that? Well, what I'm doing is I'm taking one of a set at every position. That's multiplicative counting principle. So let's count up the choices I have for this first position. Well, I'm talking about letters, right? 26 letters in the alphabet if memory serves. If I screwed that up, don't tell Mrs. Brown. So there's 26 letters for this part 1. There's also 26 letters for part 2. Didn't say they couldn't repeat. There's also 26 letters for the third part. Okay, 3 letters, so I have 26 choices, 26 choices, 26 choices. It could be K, F, F. I mean, they can repeat. 3 numbers. So if I'm going 0 through 9, that's 10 choices. So I have 10 choices here, 10 choices here, 10 choices here. So there's the counting part of the multiplicative counting principle. We count up the choices at each step. Then we simply multiply them all together. That's it. That's why it's called the multiplicative counting principle. And this is going to be a large number. So 26 times 26 times 26 times 10 times 10 times 10. I got 1,757,600. 17,576,000 ways I can make that license plate. Pretty cool, huh? Another way that you could use something like the multiplicative counting principle would be, ice cream. Let's say you go to an ice cream shop and they have, ice cream choices. So they have some sort of ice cream special. You choose a scoop of ice cream and then you choose your toppings. So let's have toppings. So I know now I want ice cream, right? So let's say we have, usually I'd ask you guys to give me choices: chocolate, vanilla. You've got to have mint chocolate chip. Cookie dough? Yeah, cookie dough. Cookie dough. You're probably screaming your favorite flavor right now and I can't hear you. What else is a good, we need peanut butter. Let's get one more up here. What's another favorite flavor? I can't hear you. Say it louder. I'm kidding. Let's put up one more flavor. Let's say strawberry. Although I'm like fruit in my dessert. If I'm gonna have some crappy dessert, don't try to healthen it up with fruit. Then for toppings, let's say we have like chocolate syrup. We would have butterscotch syrup. We could put peanut butter like sauce on it. We could put cherries on it. Those rainbow sprinkles. So RB sprinkles. You can put peanuts on it. What am I missing? Oh, marshmallow. We need to have marshmallow. Okay, we'll call it that. So we're allowed to choose a scoop of ice cream and a topping to make this, special dip that the place is selling. So really there's only 2 steps here. So the question is, how many choices do I have for step 1? Well, if I choose my ice cream, I've got 6 different choices. How many toppings do I have to choose from? Well, here I have 7. So if I just take those 2 and multiply them together, that means there's 42 different ways that I can make this work out. So as you can see, when you're doing situations like this, the more choices, steps you have, the larger the number of outcomes. And that's it. That's the multiplicative counting principle. Now let's go to that whole NPR, NCR thing. And I'm going to do 2 examples side by side. Let's say we're sitting in class. There's 21 students in my class. And let's say Dr. Shoemaker, Mr. Freed, somebody pops in and is like, hey, Goodman, we need 5 kids to come out of your class and have a picture taken for the yearbook or something. So I have 21 students and I'm going to choose 5. Well, I can't write a 5 apparently. How many ways can I do that? Well, here's where I'm doing part of a set. So this is either a combination or a permutation. So the question is, does my order matter? Well, if I'm choosing 5 for a picture, does it matter the way I choose those 5? No, it's the same 5. So whether I choose like Bob, Amanda, Jimmy, Kayla, what if I was like, no, let's go Bob, Kayla, Jimmy, Amanda. It's the same group, right? So here, there's no order. So that makes this a combination. So it is an NCR. So all I have to do is figure out what's my total number of choices. Well, if there's 21 kids in a class, my N value is 21. If I'm taking 5, or my part of the set is 5, my R value is 5. Now, Desmos people, you're doing it this way. Okay? So, grab your calculators. Let's make sure we can punch this in. So I have 21. Press my probability button. Go down to NCR. Get 5. Desmos, remember, function, NCR, put it in 21 comma 5 in those parentheses. Either way, we get 20,349. And this is usually in class where your kids go, how do you get that many choices? And we could start making a tree diagram to show you how the choices start to grow. We wouldn't finish it. It would take us days, if not weeks. But that's how it would work. Now, what about a situation where order matters? Let's say we have 10 students line up for a race. They're going to run a mile. And I am going to place first through third. So my question is, how many ways does that work out? Well, real simply, this is where, of course, if we're placing people, the order matters, which means if I have Bob, Jimmy, and Amanda come in first, second, third, that's different than Bob, Amanda, Jimmy, first, second, third, or Amanda, Jimmy, then Bob. So those same 3 students rearranged gives you a whole different set. So this time, order matters. That means it is an NPR. So in this case, our N, or our total number of choices, is 10. Our set that we want, or the part that we want, is 3, because we have 3 students we're going to place first through third. Desmos people, don't forget, NPR 10, 3. So we go to our calculator or to Desmos, and we type in that NPR 3. I'm going to wind up with 720 choices, or different ways that can work out. And you get a lot of choices out of just placing 3 people out of 10 because of that situation where those 3 pop up, and then you can rearrange those 3 and get different sets. That's why your number of choices pop up. If you want to really see the difference with that, do like an NCR and an NPR with the same numbers, same number of total and same people you want. So that's it, guys. So multiplicative counting principle is when you're taking one of a set at each stage of the game. Your Combinations and permutations are when you're taking part of a whole set. So I'm taking 3 out of 10 or 5 out of 6 or 2 out of 5,000. And what happens is, if there's no order, it's an NCR. If there is an order that matters, it's an NPR. That's as simple as I can do it. Now look, your Google form, your exit ticket, 3 questions. Guess what that means? 1 of each type. So you can reference the video, look at the notes that you have on your paper, and use that as you go through it. Hopefully that was quick and easy. That's it, guys. Welcome to the last day of school. Do your exit ticket and you're done. If you're missing anything from the past, get it done. I got to close out grades today at 3. So yeah, it's over, guys. So we have a Google Meet today. I have one for Tuesday and Wednesday of this week. So hopefully you were on the one yesterday. If you haven't been on any, pop in, say goodbye, say have a good summer. The only other thing I want to say is, if I do not see you or speak to you, I'm sorry the year ended this way. It's not what I wanted. I also know you guys are going to the high school, so I won't see you next year in the building. So have a great freshman year. I hope it starts on time and in the building and there's no problems. I wish you all the best. Have a happy, safe, healthy summer. And hey, I'm sure I'll see you around. See you guys.